All right, there are also a number of different types of experiments. This is by no means a comprehensive list. There's also crossover design. There's a lot of different designs, but these are three big ones. The first is completely randomized. So after we have all the people who are willing to participate in our experiment, we're going to call those people our experimental units over here. We randomly assign them into our treatment groups. That's it. Random number generator, flipping a coin, whatever it might be. We just randomly assign them. So in the CT program, if we were to do this as an experiment, what we would do is we'd have the list of all the CRNs, and we would just randomly choose CRNs to be part of the CT program, and all those that weren't chosen would not be part of the CT program. So experimental units do not necessarily have to be people. The second type of experimental design is a block design. So this completely randomized is very similar to sort of an SRS. Note that they are different. In an SRS, we start with a population, and then we get our sample, right? In an experiment, we already have everyone that we're going to get data on, and we're just deciding which group they're in. So it's about assignment versus selection. So while it has similar mechanics to an SRS, it is not the same thing. So block design is similar to our stratified. Since it is possible when I do my random assignment that I get some groups that are predominantly one group or another. As you can see up here in treatment 1 and 2, there's a lot of little yellow people up here, and there's a lot more maroon people down here, and then group 3 is pretty evenly spread out. So if that's the situation that I'm worried about, especially if we're doing something like a drug trial, where I'm worried the drug might behave differently for people, maybe between the two genders, between male and female, well then what I'd want to do is a block design. And that is block everybody into their similar groups, so maybe this is male and female, and then randomly assign them to their treatment groups. That way, I've got an even number of male and an even number of female in treatment number 1. So block design is very similar to stratified, but again, all about assignment versus selection. The last type of design that we'll talk about in this class is matched pairs. So it's basically a block design, but in each block there's only 2 people. So what would happen is if I'm doing this for our class and I'm randomly assigning some people that have to go to the CT sessions and some people that don't go to the CT sessions. If I chose somebody, I'll draw one of these cute little peoples, right? If I choose someone, and this happens to be a first-year MESA student, female, maybe somebody who would identify as Latinx. What I would want to do is, if this person is going to be part of my treatment, I would want to find another person who is as similar to that person as possible within the class. So I would look for another first year, if I was worried that that had some impact, female student who identified as Latinx or Hispanic, and I'd put them in the control. So each group would just have 2 people, one to go to the treatment, one to go to the control. One thing I want to point out here is a block, like I said, except for each block is as similar as possible. Is that there are some tricky ways I can talk about this. The most tricky, or some other ways we might see this, a lot of twin studies will happen this way because twins are as similar to each other as possible, right? And the other one we'll see is a before and after study, because that in a before and after study, you are your own control. So if we did like a pre and a post test, like, okay, here's how much statistics they knew coming into the class. After the class, they knew this much statistics. So clearly the class caused that learning. So those are 2 examples that you might see here as a matched pair design.